In the last chapter, we talked about variables, but we didn't specify the type of data that we can store in those variables. So, that's what I want to explain in this chapter. For that, I have a new workspace in which we're going to change the algorithm. I don't want it to say this, but I want it to say, for example, data. Very good. In PCI, we have 4 types of data that we can store: character data, integer data, real data, and logical data. Let's start with character data. Character data is the combination of any character that we have available on our keyboard. It can be a combination of letters and numbers, or symbols such as asterisks, periods, and hyphens, but in order to define it as a character, it must be enclosed in quotation marks. For example, what I'm going to do right now is define a variable called a, and we're going to assign quotation marks to this variable. These quotes can be double quotes or single quotes. Either one can be used to define character data. And we are going to use a semicolon, which, as I mentioned, is not mandatory in PCI, but it is good to get used to it, because especially when you are learning to program, after a course in algorithms in PCI, you will be taught a strict programming language, such as C++. And in C++, if you do not use a semicolon, your program will fail. So it is good to get used to using semicolons. Very good. Everything I place between the opening and closing quotes is known as character data. Here I could put, for example, hello, I could put Victor, I could put characters, or I could even put numbers, but since it is enclosed in quotes, this is considered character data, it is not considered numeric data. Next, we will see the difference, or what the difference is between defining it as a character or a numeric. Another type of data that we have is integer data. Integer data is numeric data and, as its name suggests, it is about whole values. For example, the value of 1, the value of 2, the value of 3. Decimal numeric values such as 3.5, 3.6 are another type of data. Integer data is numeric values, but only the whole part. Here we could place the value of 3, for example, or I want it to be the same value as the one above, 45. In a variable a we have stored the value of 45, and in another variable b we have stored the value of 45. What is the difference between defining it as a character type and as a numeric type? The difference lies in the type of operation that I can perform with one or the other. The first, being a character data type, I cannot perform mathematical operations. For example, let's imagine that I wanted to print the value of a +5 on the screen. I could go here, type right, and ask it to print the value of a +5 on the screen. When I do this, it's showing me an error right here and telling me that I can't add 5 to a string. So, as we can see, if I define it as a character, I can't perform mathematical operations. Unlike BB, I do know that it's integer data, numeric data. So, if I were to enter the value of b +5, the error disappears. And if I were to execute it, we'll see that it prints the value of 50 on the screen. So, you can see a difference between defining it as a character and numeric data. What other type of data do we have to store, or can we store? It's real data. Real data includes numeric values, whether they're integers or decimals. For example, in C, if I store the value of 3.5, what I'm doing is defining the real data type. And finally, the last data type that PCIN allows us to store is logical data. There are only two logical data types, and this data type can be either true or false. We're going to use this data type when we start working with control structures and want to add logic to our program. For now, I just want you to know that this data type exists. Now, while it's true that Pseint allows you to define and directly assign a value to a variable, many programming languages will require you to first set aside a memory space, and only after you've set aside that memory space can you use it to assign a value to it. So, that's what I want to explain to you right now. In order for us to first set aside a memory space and then use it to assign a value to it, what we have to do is the following. Go here and enter. I want to define a variable, for example, I want to define variable a. After specifying that I want to define variable a, I enter it here as, and specify the type of data that I want to store in this variable. For example, in variable a I want to store character data. So, I define variable a as character data and put the semicolon. The same with the other one. B is numeric data, but an integer. So, we are going to define variable b as integer data. Variable c is going to be defined as real data. And variable d is going to be defined as a logical data type. Now, when we define a variable, defining means setting aside the memory space and assigning it a data type. We cannot store data that is different from what we have previously defined. For example, here I define that I'm going to store a character in a. If I tried to store the value of 45, we can see that an error will be displayed here because this is not an integer data type, character, but an integer data type. So I would always have to define it as a character. I defined this as an integer data type, so I couldn't store decimal data. If I place decimal data here, it displays an error. I execute it, look, and it tells me that the types do not match. The assigned value must be an integer. So we return it, we return here. Very good, let's recap. If we set aside a memory space and assign it a type, it necessarily has to be that type of value that we're going to store in the variable. If not, it displays an error. Now, here's a small question you may have. We mentioned that the integer data type stores only integer values, while the real data type stores either integers or decimals. For example, in C I could store the value of tr and we'll see that it doesn't show me any errors. And if I store the value of 3.55, it doesn't show me any errors either. So why don't I simply mark all the numbers as real? For example, here I can put real, and I'm going to take this opportunity to explain something else. When we want to define more than one variable with the same typing, we can separate them with commas. For example, specify here that I want to separate, create two variables, variable b and c, and define both of them as real. Very good, why don't we simply do this? Which includes both cases, decimals, and integers. The answer is simple and it's about the amount of memory that we're going to set aside. I want to return it. As we were a while ago, that is, as an integer and real. When we define a variable as real, it's going to set aside much more memory than the one we have here. Why? Because it also needs to store decimals and therefore needs to set aside more memory. It simply sets aside more memory because it needs to store more information. So, this can be a bit counterproductive if you have few resources. So, ideally, whenever you want to store a number, you should define it as an integer, unless you need to store decimals. Only if you need to store decimals, you should define it as a real. And very well, those are going to be the data types that we are going to be able to work with in PCI. And that's it for this chapter. If you like my videos, it would help me a lot if you like the video and subscribe to the channel. Without further ado, I say goodbye and I'll see you in the next chapter.